In this video, we will calculate the volume and the number of molecules there are in a drop of water. For this experiment, it will be needed the following material: a digital balance, a stand, a burette, distilled water, and a beaker. First, let's weight the empty beaker and record the numbers we read in the balance. Now, we fill the burette with water until the meniscus is lined with 0 milliliters. Then, we open the burette's clamp and dispense 130 drops of water. The volume of these drops is equivalent to the variation between the initial and the final volume of water in the burette. The next step is to weight the beaker containing the drops of water. The mass of the drops is given by the variation between the mass of the beaker containing water and the empty beaker. The procedure must be repeated 3 times to minimize possible experimental errors. Moving on to the result analysis, here are the readings we recorded. We must bear in mind that the reading uncertainty associated to the burette is half the lowest division of the scale, while the reading uncertainty for the balance is the lowest division of the scale. Now that we have all the data we need, let's calculate the volume of a drop of water. If the volume of 130 drops is 6.5 milliliters, then the volume of the single drop is equivalent to the division quotient between 6.5 and 130, that is to say 0.05 milliliters. Presenting the result with the correct number of significant digits, we have that the volume of the single drop is 5.00 times 10 to the power of minus 2 milliliters. Now let's calculate the mass of a drop of water. By calculating the difference between the mass of the beaker containing the water and the mass of the empty beaker, we find that the mass of 130 drops is 6.58 grams. So, if the mass of 130 drops is 6.58 grams, it means that the mass of a single drop is given by the division quotient between 6.58 and 130, that is to say 0.0506 grams. Presenting the result with the correct number of significant digits, we have that the volume of a drop is 5.06 times 10 to the power of minus 2 grams. To conclude, let's calculate the number of molecules there are in a drop of water. First, we calculate the molar mass of water, 18.02 gram-mole minus 2. Then, using the given formula, we'll calculate the chemical quantity of molecules there are in a drop, that is to say 2.81 times 10 to the power of minus 3 mole. The last step is to multiply the result for the Avogadro's number, 6.02 times 10 to the power of 23, which equals to 1.69 times 10 to the power of 21 molecules of water. In this experimental activity, we learned that there are approximately 1.69 times 10 to the power of 21 molecules of water in a single drop of water.